Good day, ladies and gentlemen. Today we'll be continuing on doing our Arduino exercise 5, where we're controlling a DC motor with a potentiometer and a motor drive. So before we get started on this circuit, right, I want us to understand some of the basics of this component. So now, if you observe this circuit, right, or you can see before we go to the circuits, there's the components required. We have what we call an H bridge motor driver shield, right? So the H bridge motor driver shield, it's used to control the rotational direction of the motor and the speed of the motor. So without our motor driver shield, we can't control the motor, right? So yeah, that's a very important component to have when we are trying to control a motor, right? So yeah, try and remember. So now we'll be using the potentiometer to control the motor. So as we adjust the potentiometer, right? So if we adjust the potentiometer to a certain level of resistance, the motor speed. So this is the motor. The motor speed should increase or decrease depending on where we adjust the direction of where we adjust the potentiometer, right? So now they are saying here in this scenario, in this circuit, the potentiometer is used to control the speed of the DC motor, whereby terminal 1 is connected to the power and then terminal 2 is is connected to the ground, and then the wiper is connected to the analog input A0, right? So now they are saying the motor driver shield is used to control the speed of the DC motor through reading the value of the potentiometer and then adjusting the speed accordingly, right? So now they're also saying our our motor is powered by a 9 volt battery, right? So this is our circuit, right? So now we'll go and build that in Tinkercad, right? So now uh, this is what your circuit should look like in Tinkercad, right? So now, as you can see, our H bridge has different outputs under it, different variables under it, right? So now what we'll do is we'll start programming uh, we're programming our circuit to be able to rotate the motor, right? So first thing we have to do, right? We have to create a variable, right? That's gonna read that's gonna read the value of the potentiometer, right? And then if you still remember, right, our potentiometer is an analog signal, right? So it has to be reading the value from an analog signal, right? So okay, before I start writing my code, right, you can see the wiper here under the potentiometer is connected to the analog signal, so that the value of the potentiometer will be a reading from analog signal 0, right? So now I create a value that's gonna contain the value of of A0, right? So it's gonna read the signal from A0, right? So now I'm gonna set that potentiometer to read its value from A0, right? So I'm gonna go here, right? And then I'm gonna tell it to read analog signals, right? Since the potentiometer is an analog component, it can't be reading digital signals, so it has to read analog signals. And since we connected it to A0 here, as you can see, it has to be reading them from that, right? And then also gonna create another variable that's gonna read the output that's produced by pin 5, right? So pin 5 is directly connected to our motor driver shield, right? So now we're gonna create another variable that's gonna read an output signal. So I'm just gonna name this variable output, right? So now I'm gonna I'm gonna go to output, right? Then I'm gonna set pin 5 to read the output, right? And then now define we have to define the output, right? So our output is that we'll set it to we'll be setting it to the potentiometer, right? So now what is this like this what this function block is saying we'll set our output, right? We'll set our output to pin 5, right? So output is the thing it is the signal coming from pin 5 going to our motor, right? So then that output is going to be equals to the value of the potentiometer divided by 4, right? So we divide by 4 so we can regulate the speed of the potentiometer, right, relative to our motor, right? And then so now we'll simulate this circuit, right? So now when we are simulating it, as you can see, our motor is rotating, right? So now if I adjust the speed of the potentiometer, you can see the speed of our motor is also increasing as well. So more I adjust goes up, and then if I reduce it down, so if I go down, it also goes down. So now say I wanted to be able to see these values adjusting, right? So now there's what we call a so if I stop the simulation, so there's what we call a serial monitor, right? So this can help you demonstrate the change in values, right? So how we add the serial monitor to see how far we've adjusted our potentiometer, right? We just have to go to our output, right? And then you look for print serial monitor. So now we're trying to print the value of the potentiometer, right? So we go take our potentiometer, right? So now when we run this, right, we'll be able to use the serial monitor to be able to see the value, the current value of our potential. So like if now I start the simulation, right? So now you can see as I adjust the potentiometer, you can see the value of the resistance of the potentiometer increasing, right? Then when I go back down, you can see the value of the potentiometer reading. So the serial monitor is a very important it's a very important function block as it helps us be able to read the current value of our potentiometer without having to adjust its resistance, right? So basically that's how we use a potentiometer to control our motor, right? So moving on to the next exercise, right? So now this exercise will be using a we'll be using we'll be learning how to program a stepper motor, right? So as you still remember me from your automation, a stepper motor converts electrical pulses into angular displacement. So like now, in simplest terms, so like now the motor uses rotate in step angles. So now with the motor, you have to define the number of steps and then the step angle, right? And then so now if you define the number of steps and the steps angle, your motor will know how many steps should it rotate per minute and the step angle, right? So now we'll be learning how to control our motor, right? So if you still remember from our previous exercise, right? we're using a motor driver shield to help us control our motor, right? So now here, right, we'll also need what we call a a 5 wire 4 phase drive port, right, or a motor driver port, right? So our motor driver port helps us to control our stepper motor, right? So this is our driver port, right? And then this is our microcontroller, and then this is our stepper motor, right? So now we can't do this exercise in Tinkercad, right? Because the 5 wire 4 phase drive port doesn't exist on Tinkercad. So I'll just be showing you how to program it in the Arduino software, right? And hopefully I will create a demonstration for you, right? So now if you go to your Arduino software, right, or your IDE, right? So now this is your Arduino development environment, right? So in your Arduino development environment, if you still remember, even from Tinkercad, right? We have the void set up. This is where you put your code that you're gonna run once, and then under void loop, it's where you're gonna put your code that you want to run indefinitely, right? So now I'm just gonna take this out. Right? So now starting our motor, right? So if you can say this, right? So this is the stepper motor, right? So we have to first what we have to do, we have to call in a package or a library that consists or that has stepper motor functions, right? So this library, if you know like something like Python, if you want to do numerical analysis or data analysis, there are certain packages that you have to import. So like here, like by calling that package, it gives us control, gives us the power to be able to control the stepper motor, right? So now how we call that package is we say hashtag, right, and then include, right, and then so now we call in our stepper motor. So this is how we call in our stepper motor, right? And then now after we have called in our stepper motor using the by including its package, right? Now what we have to do is that we have to define the number of steps that the stepper motor takes in a full rotation. So right now we say hashtag, right, and then define. So we define the steps to 100, right? So this is basically saying that it's basically saying like in one full rotation, I want the stepper motor to have 100 steps, right? And then now, after defining the steps, right? So now you go to, so now after defining the number of steps, you go to your, and I avoid setup, right? So under your void setup, right? Okay, before we go to our void setup, right? So I want you to try like and also like comment like so that you understand what you are doing. So now, for example, here you are saying you are you are setting your stepper motor to have 100 steps in a full rotation, right? So as I said, like you are telling it that your number of rotations in one full rotation will be equals to 100. And then here you'll say, for example, so make sure you double slash before commenting so your code doesn't have error. So here you are importing the package to control the stepper motor, right? So yeah, this is very important. So like you show that you're understanding, or if let's say someone who's reading your code is trying to understand what you are doing. So like it's very important for you guys to learn how to comment, right? And then so what next you do, right? What you do next, right, is that you define the pins that your stepper motor is connected to. So now how you do that is that you say stepper stepper, right? And then you open bracket, right? And then you say steps, right? So now if you go back and look at your stepper motor right here, it's connected to pin number 11, 10, 9, and 8, right? So now we have to define that. So you say 11, 10, 9, and 8, right? And then you have to put a semicolon at the end. So now here in this line, you are setting the number of pins that's connected to the stepper motor, and you are also relating it to the number of steps in one full rotation, right? So now these steps here, right, it relates to 100. So like sort of like we're putting 100 here, like by defining number of steps in full rotation, right? So here when you comment is that you are defining the pins that the motor is connected to through the drive port, right? And so now what you do next, right, is you go to your so now you have to also define a variable, right, that's gonna store the previous readings, right? So now you will like understand the importance of me creating this variable now. So like now I just like to say, so this variable is gonna store the readings of the previous the previous the readings of the previous speed of the stepper motor. So now you wanna equate it to 0 because our stepper motor starts at 0, right? So now under here you comment that you are defining a variable to store the previous readings, right? So now you'll see the importance of me creating this variable now, right? So now you go to your void setup, right? So under your void setup, you will be defining the speed of the motor, right? So now how you do that is that you say step. So let me just leave a line for commenting, right? Then you colon. So now you say step. So fetch has to set the stepper underscore set speed to 90, right? So now here, what you are doing is that you are setting the the speed of the motor to 90 steps per minute, right? So now here it's like you are telling your motor that each minute it's gonna be rotating 90 steps, right? So okay, so now you are done here under your void loop, right? So now you are trying to, so now we go under void settings. So under void settings, so we're gonna define our code that we want for it to run indefinitely, right? Or in a loop, right? So now you're gonna, so now going back to your circuit, right? So now, as you can see, so like now I'm gonna also create a variable, right? So if you still remember, I told you that your motor, a motor, it's an analog component, right? So it has to be controlled using analog signals, right? So now we'll create a value that's gonna read these variables from analog read 0, right? And then semicolon, right? So now here you are telling the motor to read the analog signals from A0, right? And then from then on, right, you are gonna be defining the number of steps you should take per angle, right? So now by doing that, right, you're gonna say stepper to step, right? One previous set. So in this line where you are subtracting the value minus the or val minus previous. So now your stepper motor, your initial position of the motor is gonna be 0, right? So from 0, your stepper motor is gonna move to 1, right? And then that variable, it's gonna be the current value or the current position of your stepper motor. The val is gonna be the current position of your stepper motor, right? And then when your stepper motor moves, let's say it moves from 0 to 1, your previous is gonna be 0, right? And then when it moves from 1 to 2, your previous is gonna be 1. And so like now our stepper motor is gonna be, for it to be able to keep the positions or the step angle constant, it has to be minusing the current position from the previous position, so it doesn't increase speed exponentially, but it increases step by step, right? So now this is basically what you are doing there, right? So now these variables, the val and the previous, all of the variables, like they are stored inside there, right? So now when you are subtracting the val minus the previous, it's sort of like you are telling your motor that you want it to rotate at a constant speed angle, right? So now here you're gonna comment that you are keeping the number of steps, number of steps, let's say, keeping number of steps constant, right? So that's basically okay. So like, let's be more into, so you'll say you are keeping number of steps constant for, let's say, each, say, iteration or rotational movement, right? So now that's basically what you have to. So now one last thing you have to do, right, is you have to come here, right, and then you have to say the previous, right, should be equivalent to val, right? So now, okay, so let me think this is a typing error. So let me just try and fix it, because if it's not fixed, it will give us an error, right? So now you're equating the previous to val, right? As I told you, the previous stores the previous value. Like, let's say if your step motor Z1, the previous is gonna be 0, right? So now every time your stepper motor moves, it's gonna be updated on the analog signal A0, right? Which is gonna update to the current one, right? So now the previous is gonna become the previous. So like now, so I'm trying to think of a way like to explain this which doesn't confuse people, right? So now when you are creating when you're previous to your val is your current position, right? So now if you move to the next position, the previous has to store the previous position that your step motor was at, right? So it could be able to subtract it from here and then maintain a constant speed, right? So that's basically what we are doing there, right? Okay. So now here you're saying you're updating both the positions of, so you say previous, you're updating it to get the historical, you can say historical or historical or previous reading, right? So yeah, so like now, let's say you have this connected to a board, right? So now what you'll do is, let's say if I had a board connected, so now if I had a board connected, I would select that board here, right? And then I would validate my code, right? So now since there's no board connected, right, it's gonna give me an error. But now let's say if there was a board connected, right? So it would be, so here you are sort of like you are compiling your with this pattern here. You are compiling your code, right? And then after compiling it, this arrow here is to upload your code onto the microcontroller board, right? And then now your circuit will run. So like with this, like currently I don't have access to a board, but I'll try and create a demonstration of how your motor is supposed to work in real time. So now we're gonna move to exercise number. So we've done exercise number 5 and 6, right? So now we'll be moving to exercise number 4, right? So in our exercise number 4, so let me just try and go there. So in our exercise number 4, we'll be measuring a distance using an ultrasound sensor, right? So an ultrasound sensor, it's used to detect the proximity of an object that is approaching or moving away from the sensor, right? So now here they're saying when the sensor reaches the object at a distance greater than 150 centimeters, the green light will turn on, right? And then they're saying when it reads an object at a distance equals to 100, the blue light turns on, right? And then they're saying if the distance is less than, if the distance, they're saying if the distance is greater than 150 centimeter, the green light should turn on, right? And then for the blue light, it should be equals to 100, right? And then for if the sensor reaches a distance less than 50 centimeter, the red light should turn on, right? So now this is our components are required, right? So now make sure that your ultrasound has 4 pins, right? It's a 4-pin ultrasound distance sensor, right? So now this is our circuit, right? So now let me just try and see if I've tried and build this circuit, right? So now I'm just gonna try and build this circuit, right? So this one, let's two, let's three. So now I'm gonna check for the make sure you have the correct resistance. So here they say the resistance is 330 ohms for all of the resistors, right? So now I'm gonna set them to 330 ohms. Right. So I'm gonna be setting all of them to 330 ohms. Right. So now I'm gonna finish up connecting my circuit, right? So now this wire is connected to pin 13. And then this one is connected to pin 12. Number 11, right? And then now we connect our ultrasound distance sensor, right? So now the ground. So now, and for ultrasound distance motor, right? We have like we have 4 pins, right? So we have the VCC. So the VCC, right? It's our power. It's where we power our ultrasound distance sensor from, right? And then our ground it's like our negative or our zero, right? So where power goes back to. And then we have the trigger and the echo. So now the trigger. So now how our ultrasound distance sensor works is that it sends out a signal, right? So our signal is sent out through the trigger, right? And then after it sends out a signal, that signal is gonna bounce off a surface, right? So that surface, it sends out back like sort of like an echo. So the echo pin is to read that outcoming, or like that signal that's coming straight to back to our sensor, right? So it's able to detect how far that object is, right? So it sends out a signal to a surface, and then goes to the surface, bounces back, goes back to the motor, right? So that's how our it goes back to the sensor, right? So that's how our ultrasound distance sensor works, right? So now we connect our VCC to the power, right? So just from here to the power, right? And then our ground will connect it to the negative terminal, right? And then our trigger will connect it to pin number 6, right? So let's take our trigger and put it to pin number 6, right? And then we'll connect our echo to pin number 5, right? So now, mm, so now let's change this color to blue, right? And then we change this color to green, right? So now this is our entire circuit, right? So now we will be programming the circuit, right? So you go to code, right? And then obvious you take this, right? And then now we have to create a variable that's gonna store the distance of the sensor, right? So now we go out to variables, right? And then we create a variable that's gonna store the sensor distance, right? Distance, right? So now again, so now we have to set this sensor distance, right? It has to be reading its variables. So now, as you can see, we have the ultrasonic read block, right? So this is going to be defining our trigger and our echo pin, right? So it's able to measure the distance. So you still remember how I just explained to you how ultrasound distance motor works, right? So we're putting it here, right? So let me try and reduce. Okay, now it's fine. Right. So now with our ultrasound distance motor, so we'll set the trigger pin. If you can see, our trigger pin here is connected to 6. So we'll set our trigger pin to be 6, right? And then our echo pin, right? Our echo pin will be 5, right? So you have to also make sure that this it's in centimeters, right? So if let's say you had a 3-pin motor, right? You would have to set the echo pin to be similar to the trigger pin, right? But since we have in our ultrasound distance sensor, we have the echo and the trigger. So we'll set our trigger to 5, right? Hello. Okay. So so now, as I was saying, we'll set our our trigger to 6 and then our echo to 5, right? So now if we are trying to create a value that's gonna differentiate between the three distances, so we have like, so it's gonna measure a distance, right? And then depending on that distance, it's gonna change a light, right? So now we have to be using if conditions, right? So now our first if condition, right, is we say if, right? Now if, right? So now we also our math function, right? So now our math function will be using intervals, or yeah, I can say intervals greater than equals to those types of distances, right? So now we say if, right, our center distance, if our center distance is greater or it's or equals to, right? So less or equals to, so they said, so it's less or equals to 50, right? Then we want it, so we want to set, so now we look for the color that we connected our red pin to. So now if our red pin, so we want to set, so now we want to set, we want to set pin 13. So this is for the red, this is for the red light. So I want to set pin 13 to high, right? Or else want to set our pin 13 to low, right? So this is telling us if the distance is less or equals to 50, right, our pin will be at high, right? And then if it's not there, our pin 13 will go to low, which means it will switch off, right? So now we'll also do the same for, we'll also do the same for the blue and the green light, right? So now we also, so now just not to make sure I don't keep coming back, drag to if function, right? And then I'm gonna say if again, right? Let's put this here, also put this here, right? And then also get this and this, right? So now, right? So now for the right. So let's say our distance is between, it should be greater than 50. So now we'll say if the center distance, right? If the center distance is greater than 50, right? But it should be less than 100, right? So if our center distance again, okay, yeah, so it should be less than 100, right? We we want to set, so like now our blue light is connected to pin 12. So now I want to set pin 12 to high, right? And then if our ultrasound distance doesn't read an object outside that range, we want it to turn off. So we have to set, also set pin to low, right? So now that's how we do it for our red. So now we have to make it now that if our distance is greater or equals to 100, right? Want the red, want the we want the green light to turn on, right? So now we want to set, so now green light is connected to pin 11. So now we want to set pin 11 to high, right? If it's our distance greater than 100. And then if it's that's not the case, to set our pin 11 to low, right? And then if we run this, right? So now as you can see, our distance is greater than 100. That's why the green light is turning on. But when we move closer, the blue light turns on. And then when we move less than, the red light turns on, right? So now this is how you use an ultrasound distance sensor to be able to detect your distance, right? Right. So now one thing that I also want you to be aware of, right? So now as you're doing this in blocks, it's also being created using text on the other side. And that text, that's the text you can use to paste on your Arduino software, right? So now if you come here and then you say blocks plus text, right? As you can see now, your code, it's being written in the C++ language, right? So yeah, so that's basically it. So now this is our last exercise, right? So thank you very much, ladies and gentlemen.